All right, so this video is going to go over 4.2 notes. Starts by asking us to use a calculator to approximate the square root of 30.1, rounding our answer to the nearest hundredth. Remember, hundredth means two numbers after the decimal. All right, so plugging this into our calculator. So here's the calculator. Turning it on, we want to do the square root. So right here to the left of the 7 is the x squared button. Above the x squared, you'll see the square root. It's in light blue. That means that I need to hit my second light blue button first. And then the x squared button to give me the square root of 30.1. If you want to close your parentheses, go for it. Press enter. So we get 5.48634,669. So going back to our notes, in our calculator, we got 5.486 blah, blah, blah. It asks us to round to the nearest hundredth, two numbers after the decimal. So this 8's in the hundredth spot. Looking next door is a 6. That means that 8's going to round up. So we have about 5.49 as our final answer. So next we have what's called the Pythagorean Theorem. The Pythagorean Theorem is super important, and it helps us, super useful I should say, and it helps us to find the side lengths of a right triangle. So this only works for right triangles. Remember, right triangles have one right angle, and that right angle is shown by this little square in the corner. So here we have a right triangle with the sides are labeled A, B, and C. So our Pythagorean theorem, and this is super important if you want to put this on your index card. If you don't know it, it tells us that A squared plus B squared equals C squared. And we're going to use this to do the next couple examples to find the side length. Notice A is a leg, B is also a leg of a triangle, and this C is this long distance, and notice it's across from the 90 degrees. This longer side is called the hypotenuse. The hypotenuse. So really we have A, which is a leg of the triangle, squared, plus B, which is another leg of the triangle, squared, equals that long side, which again is our hypotenuse, squared. All right, so let's do an example. So it says for the following right triangle, find side length x, round to the nearest hundredth when needed. So I have 9 as a leg, 40 as a leg, and then we have this long side across from the 90 degrees as our hypotenuse. So I can label this and say, okay, A is 9, B is 40. It doesn't matter which one which one's A or B because they're both just legs and we're adding them. So remember, we can add in any order. And then this C, this x value is our hypotenuse. So plugging into our a squared plus b squared equals c squared formula, we said a is 9, so 9 squared plus b is 40, so 40 squared equals c squared, which you said was x. So in our calculator, 9 squared, 9 times 9 we know is 81, plus 40 squared, 40 times 40 is 1600, equals x squared. Combining like terms, 81 plus 1600 is 1681 equals x squared. Now we want to solve for x. We want to get x by itself. So that means I need to get rid of that squared. The opposite of squared is square root. So what you do to one side, do to the other. So I'm going to take the square root of both sides. That way the squared and the square root cancel each other out. Just like adding and subtracting are opposites, they cancel each other out. Multiplying and dividing are opposites, they cancel each other out. Squared and square roots are opposites, they cancel each other out. So we're just left with x equals the square root of 1681. Now in our calculator, the square root of 1681, just like we did that previous problem, will give us 41. So our x value here, that x length, the hypotenuse length, is 41. Let's do another example. For the following right triangle, find side length x, round to the nearest hundredth. Let me start off by labeling A, B, and C. So for one, starting off this 13 side is across from our 90 degrees, so that'll be C, and then our other two lengths will be our A and our B. So A is X, B is 9, and C is 13. Going back to our Pythagorean Theorem formula, A squared plus B squared equals C squared, plugging in our A, B, and C values. A we said was X squared plus B we said was 9 squared equals C we said was 13 squared. So X squared is X times X. We're just going to leave that as X squared. 9 squared, 9 times 9 is 81. Equals 13 squared, 13 times 13 is 169. Now getting X squared by itself, first we have that plus 81. We need to get rid of that plus 81 first, so we're going to do the opposite. We are going to subtract 81 from both sides. That way 81 minus 81 goes to 0 and cancels out. We're left with X squared equals 169 minus 81, which in our calculators will give us 88. And now getting rid of that squared, we said the opposite of squared is square root. So we're going to take the square root of both sides. So that way the square and the square root cancel each other out. We're left with X equals, in our calculator, the square root of 88 will give us 9.3808, blah, blah, blah. It tells us to round to the nearest hundredth. So that means two numbers after the decimal. So looking after our decimal, our second number is 8. Looking next door is a 0. So that X value is going to be about 9.38. Looking next door is a 0, so it's just going to stay an 8. So X is about 9.38. Next example, for the following triangle, find side length X, round to the nearest hundredth if needed. So we have 16, we have 12, and we have X. So across from our 90 degrees will be our hypotenuse, will be our C. So C is X. The other two lengths will be our A value and our B value. So A is 16, B is 12, C is X. Plugging into our Pythagorean Theorem formula, A squared plus B squared equals C squared. We have 16 squared plus B, which we said was 12 squared, equals C, which we said was X squared. So in our calculator, 16 squared, 16 times 16 will give us 256. Plus 12 squared, 12 times 12 will give us 144. Equals X squared. 256 plus 144 in our calculators will give us 400. So 400 equals X squared. Getting X by itself, we need to get rid of that squared. So we're going to take the square root of both sides. That way the square and the square root cancel each other out. The square root of 400 in my calculator gives me 20. So 20 equals X. So we got X by itself. That is our final answer. One more of these before we move into our last concept for this section. A kite is flying in the air and has a 10-foot line attached to it. The line is pulled taut and casts a 9-foot shadow. Find the height of the kite, if necessary, round to the nearest tenth. So they give us this picture, and it shows us across from the 90 degrees is our hypotenuse, which is 10. So our C value is going to be 10. Our other two side lengths are going to be A and B. So we don't know what A is, we'll call it X, and then B is 9. So plugging into our Pythagorean Theorem formula, A squared plus B squared equals C squared. We said A, we don't know, so we're going to call it X. Plus B, we said was 9 squared, equals C, which we said was 10 squared. So X squared, X times X is just X squared. Plus 9 squared, 9 times 9 is 81. Equals 10 squared, 10 times 10 is 100. Getting X squared by itself, let's get rid of that 81 first. It is plus 81, so we're going to do the opposite and subtract 81 from both sides. Oops. And we're left with X squared equals 100 minus 81, which will give us 19. Next, getting X by itself, we need to get rid of that squared. So the opposite of squared is square root. So taking the square root of both sides. We are left with X equals the square root of 19, over here, which in my calculator says 4.358, blah, blah, blah. And it asks us to round to the nearest tenth, one number after the decimal. So we're going to round this 3. Looking next door is a 5. So we say that x is about 4.4. Here, they did give us some units. It says feet. So that means we have to put our units. So 4.4 feet. So you have to put your units because they do give us our units there. All right, so that is our first formula that we dealt with, the Pythagorean theorem. Next, we have what's called the distance formula. This is another super important formula that we're going to use, so I would suggest putting it on your note card. The distance formula says given 2 points, and we can label those 2 points as x1, y1 and x2, y2. Very similar to our slope formula. Actually, the slope formula is found using this distance formula. That the distance between those two points are the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's do an example. So it says find the distance between the points 0, -4 and -5, 1, rounding our answer to the nearest hundredth if needed. So I can label this first point 0, -4 as x1, y1, and our second point -5, 1 as x2, y2. And then just plug it into our distance formula. So x2 minus x1 squared plus y2 minus y1 squared. I always write the formula out, 1, every time I write it. It helps me to memorize it. Also, whenever I have it right in front of me, it's less likely that I make mistakes. So the square root, now plugging in our values. X2 we said was -5, minus x1 we said was 0, squared, plus y2 we said is +1, minus y1, which we said was -4, squared. So the square root, we have -5 minus 0, which is -5, squared, plus -1 minus -4. So if this helps you, remember 2 negatives make a positive, so it's really 1 plus 4, which will be 5 squared. So the square root, -5 squared. So make sure whenever you put it in your calculator, you have to put those parentheses. So -5 times -5 is +25, plus 5 squared, +5 times +5 is also 25. 25 plus 25 will give us the square root of 50. So in our calculators, putting in the square root of 50, we get 7.071, blah, blah, blah. Rounding to the nearest hundredth, so that means 2 decimal places. So we're going to round this 7. Looking next door is a 1, so it's going to stay about 7.07. No units here, so that'll be our final answer. Last example for this notes section, find the distance between the 2 points given. That is, find the length between point A and point B, rounding our answer to the nearest hundredth. So they give it to us on this chart, on this graph. So I can use this graph to have an x value, an x-axis and a y-axis. And it tells us our scale is 1, so that first ordered pair is going over 2 and up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this first point is the ordered pair over 2, up 10. The second point we're going over to right here, so 1, 2, 3, 4, 5, 6, 7. Over 7, up 1, 2, 3, 4, 5. So the second point is over 7, up 5. So now we have 2 points, 2, 10, and 7, 5, and it's exactly like the previous problem now. I can label this first ordered pair as x1, y1, my second point as x2, y2. Plugging these values into our distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. So plugging in our values now, the square root x2 we said was 7 minus x1 we said was 2 squared plus y2 which we said was 5 minus y1 which we said was 10 squared. So simplifying, the square root, 5 minus 2 will give us 5 squared, plus 5 minus 10 will give us negative 5 squared. Hey, look, that looks very similar. So the square root, positive 5 squared, 5 times 5 is 25. Plus, make sure whenever you put this into your calculator, you put it in exactly like you see it with the parentheses. So negative 5 squared, negative 5 times negative 5 is positive 25. So 25 plus 25 will give us the square root of 50, which in our calculator is going to be 7.071, blah, blah, blah. Rounding to the nearest hundredth means 2 decimal places. Is Charlie up? Sorry. Which would round to 7.07. And that's our final answer. Oh, by the way, it says units. So usually put 7.07 units. And that is 4.2 notes.